We're going to find the volume of the solid of revolution obtained by rotating a region bounded by the line y equals 3x, the parabola y equals to 4 minus x squared, the x-axis. These actually form two regions. We want one that's in the first quadrant. And we're going to rotate it about the x-axis. And we'll solve this by using both the washer as well as the shell method. We'll use both methods to show how to find the volume of the solid of revolution. So first let's sketch this region. The line y equals 3x looks something like that. Here's the parabola. It opens down. You see there are 2 points of intersection between the line and the parabola. And right here we have the line, the parabola, and the x-axis. This is in the first quadrant, the region that's formed by all three of them. But also in the third quadrant, here is the line, here is the parabola, and here's the x-axis. So this is the region that's formed in quadrant number 3. Since we specified that we want only the region in the first quadrant, it is this region that will be rotated about the x-axis that will generate the solid of revolution. Let's find the point of intersection. We just need the x-coordinate for the washer method, and we'll need the y-coordinate of the point of intersection for the shell method. So we set 3x equal to 4 minus x squared. And that's x squared plus 3x minus 4 equals 0. X plus 4 times x minus 1 equals 0. X is either minus 4 or 1. Minus 4 is the x-coordinate of the point of intersection in the third quadrant. Since we don't need it, we'll just keep x equals 1. And then plugging that into the parabola or the line, we see that when x is 1, y is going to be 3. Let's graph only the portion that we need to generate the solid of revolution. So this is the line, and this is the part of the parabola. When in the parabola, when y is 0, x is 2 right here. And of course this is 1, and then the y-coordinate is 3. So first we're going to use the washer method. As this is rotated about the x-axis, we're going to have two integrals. First, if x is over here, it actually will be a disk and not a washer. So here is the disk that's generated, and then if x is over here, we're going to have another disk that's generated. So the volume is going to be, first for the part generated by the line, it will be pi times the integral from 0 to 1, 3x quantity squared dx. That's the first part of the volume, plus pi times the integral from 1 to 2, and then it's the parabola, so it's 4 minus x squared quantity squared dx. We have to evaluate these two integrals in order to obtain the volume of the solid of revolution. So the first integral, we have 9 pi integral from 0 to 1 x squared dx, and this is 9 pi times x cubed over 3 evaluated from 0 to 1. 9 over 3 is 3, so this will equal to 3 pi. And the second integral, we have to expand 4 minus x squared squared. That gives us pi times the integral from 1 to 2, 16 minus 8x squared plus x to the 4th. And this gives us pi times 16x minus 8/3 x cubed plus 1/5 x to the 5th evaluated from 1 to 2. So this is pi times, when we plug in 2 we get 32, and then when we plug in 2 for x, we get 64 thirds. So it's 32 minus 64 thirds plus 32 divided by 5 minus 16 minus 8 thirds plus 1 over 5. And so let's simplify that. We have pi, and then 32 minus 16 is 16, minus 64 thirds minus a minus, that's plus 8 thirds, that's minus 56 thirds. 32 over 5 minus 1 over 5 is 31 over 5. So the common denominator here is going to be 15. This is pi times 16 times 15 is 240. We have to multiply 56 by 5. That's going to be minus 280. And then 31 will be multiplied by 3. That will be plus 93. All divided by 15. So this is equal to 53 pi over 15. Now remember, we also had the 3 pi. So the final answer is 3 pi plus 53 pi over 15. And that's 45 pi plus 53 pi divided by 15, which is equal to 98 pi over 15. That's the final answer using the washer/disk method. Now let's solve the same problem using the method of cylindrical shell. So I'm going to redraw this region first, though. We take y equals to 4 minus x squared and solve for x. X squared is equal to 4 minus y. X equals plus or minus square root of 4 minus y. Since we are in the first quadrant, x is positive. X is positive square root of 4 minus 4y. So we draw this region again. And we have the line part here, the parabola part over here. That's 2, and that's 3, and that's 1. We actually don't need anything on the x-axis. We now are going to take a typical y between 0 and 3 and track horizontal slice of the area as it moves across the axis of rotation 180 degrees and then 360 degrees. It generates the cylindrical shell that looks like that. This part right here is x equals to square root of 4 minus y. This is the line. When we solve it for x, it's 1/3 y. So we have to find the volume of this solid of revolution by using the shell method. Remember how that works. The volume will be 2 pi. We're taking y's between 0 and 3. The radius is y because we're rotating about the x-axis. So the radius is y, and the height is the difference between this point and this point. So it is square root of 4 minus y minus 1/3 y dy. So we have to evaluate this integral and hope that we don't make any mistakes and it ends up being 98 pi divided by 15. So let's break this down into also two separate integrals. We have 2 pi times the integral from 0 to 3 y times the square root of 4 minus y dy. And the second integral would be minus 2/3 pi times the integral from 0 to 3 y squared dy. Let's do the second integral first. We have 2/3 pi times 1/3 y cubed evaluated from 0 to 3. So 27 divided by 3 is 9. 9 divided by 3 is 3 times 2 pi. We get 6 pi. The second integral is 6 pi. We're going to subtract 6 pi from whatever we get in the first integral. So for the first integral, we'll make the following substitution. We're going to let u equal to 4 minus y. Then y is equal to 4 minus u. When u is equal to 0, y is going to be 4. and when u is equal to 3, y is going to be 1, and du is minus dy, or minus du equals to dy. Let's go ahead and substitute. I'll keep this integral up here. We have 2 pi. Integral now will run from, notice that 4 is on the bottom, 1 on top, because when y is 0, u is 4. And then y, which is 4 minus u, times the square root of u times minus du. Now the minus du can change the order of integration, so this is equal to 2 pi times the integral from 1 to 4, and then 4 minus u square root of u du. And that's because we minus multiplied by an integral reverses the order of integration. So again, we have two integrals. The first one will be 8 pi times the integral from 1 to 4 square root of u du. And the second integral is minus 2 pi times the integral from 1 to 4, and that's u to the 3/2 du. So both of these are relatively easy integrals. So let's go ahead and integrate. We have 8 pi. The integral of square root of u is 2/3 u to the 3/2. That's evaluated from 1 to 4. So this is equal to 16 pi over 3. And then plugging 4 in, we get 4 to the 3/2 is 8 minus 1. So this is equal to 16 pi over 3 times 7, which is 112 pi divided by 3. In the next integral, we have 2 pi u to the 3/2, so this becomes 2 pi times 2/5 u to the 5/2 evaluated from 1 to 4. So that's 4 pi over 5 u to the 5/2 evaluated from 1 to 4. Plugging 4 in, we get 32. 32 times 4 is 128 pi over 5. And minus, plugging in 1, we get 4 pi over 5. So this is 124 pi divided by 5. And our answer is 112 pi over 3 minus 124 pi over 5. And then, of course, we had 6 pi subtracted before, minus 6 pi. We have to evaluate this. So this is the common denominator is once again going to be 15. We're going to multiply 112 by 5. That's going to be 560 pi minus 124 times 3 is 372 pi. And then we're going to multiply 6 by 15. That is 90. So minus 90 pi all over 15. 560 minus 372 is 188. 188 minus 90 is equal to 98 pi divided by 15. So the answer is the same as it was when we evaluated this using the washer disk method. For more